Hey there, today we're going to be talking about determining a planet's habitability, which is its ability to host life. Our planet of interest is Mars. Ever since we learned of the potential water sources on the planet, it's received quite a bit of attention. So let's take a look at whether Mars is habitable, starting with what makes a planet habitable in general. First, we take a look at planetary composition. In order to determine habitability, we need to determine if a planet houses the necessary elements to support life. These are silicon, phosphorus, oxygen, nitrogen, carbon, and hydrogen, or SPONGE abbreviated. Mars contains almost all of these elements, but that doesn't cut it. In order to be considered habitable, a planet needs to possess all of these elements. And we're pretty sure that the Martian surface is uninhabitable, right? But there are exceptions to any rule, as we'll find out later. Moving on, let's talk about the physical composition of Mars. We'll start at the center. Mars's core is made of iron, sulfur, and nickel, somewhat similar to ours. However, unlike Earth's core, this one doesn't vibrate or move, meaning that the planet has no magnetic field while Earth does. As a result, the surface of Mars is pummeled by radiation, which contributes to it not being habitable. Its mantle is made of oxygen, iron, silicon, and magnesium for the most part, nothing too crazy. The crust is very dusty and gains its red color from rusting, and the atmosphere is very thin and dominated by CO2 at about 95%. The surface is dotted with volcanoes, some active and some not, which are potentially remnants of a runaway greenhouse effect, which we'll talk about later. And by the way, if you want to see that runaway greenhouse effect described in detail, you can go to the links. Now let's talk about the big topic, water on Mars. Looking at its surface, we can see that there is no water. However, there's evidence to suggest that there may have once been water, that Mars was once similar to Earth. The surface is pockmarked with craters and valleys that seem like they once held water, and we've found samples of ice in the Martian soil. It also appears that there are some ice pockets under the surface. As recently as 2018, scientists have actually discovered the existence of a potential underground lake of water found via probing the planet's ice caps. This furthers the idea that the planet was once in the habitable zone of our Sun, which we'll discuss next. Another important factor in determining whether a planet is habitable is the habitable zone, specifically the Circumstellar Habitable Zone, or CHZ, which is the distance from a star, our Sun in this case, at which liquid water is viable. If you take a look at the graphic to the right, you can see the conservative habitable zone and the optimistic habitable zone. Earth easily falls into the conservative zone, and as we can see, Mars is also there. Previously, it likely wouldn't have been included in that region, but with the potential discovery of liquid water on the planet, in addition to several exoplanets in the region that may house water/life, it now has potential. However, it's clear that Mars doesn't have any visible water sources. As for what lies under the surface, we still don't know for sure, but things look promising. So now that we have identified some of the steps to take to determine habitability, let's make a verdict on whether Mars is truly habitable. Is Mars habitable? The short answer is yes and no. For human beings, the planet is inhospitable. However, with the discovery of ice pockets and a potential underground lake of liquid water, it's definitely possible that life exists on the planet in some form. When you factor in organisms that can survive in extreme conditions, mainly certain species of microbacteria and the likes, there's a high possibility that some form of microbial life exists underneath the surface of this planet. It isn't gray anthropomorphic Martians, but this is potentially a huge discovery. If life can be supported on the planet in addition to it housing water, then it has potential to us as a planet that could be terraformed and made livable for human beings. But more importantly, it would further the idea that life is possible on planets outside of Earth. Thanks for watching the video. Here's a links page that goes in more detail about some of the topics I discussed. And for those of you wondering what a runaway greenhouse effect is, I'll explain it now since I forgot to include it in the video. Runaway greenhouse effect refers to the carbon cycle on our planet, which is normally regulated by carbon entering the atmosphere and being weathered away. However, when it gets too intense, carbon can dominate the atmosphere, resulting in extreme temperatures and generally high levels of volcanism, which would explain all the volcanoes on Mars's surface. So what likely happened is that Mars underwent a runaway greenhouse effect and as a result became inhospitable. However, you may be wondering, how is that possible when it's so cold? Well, the answer is that the habitable zone of our sun likely changed and now Mars has fallen outside of it, which is why it's so cold. Because the heat of a planet is determined by the distance from the sun. So the closer it is, the hotter it is, and the farther away, the colder it is. And anyways, that basically describes that. So thanks for watching.